Do you truly grasp the essence of time? You check your wristwatch, sense the weight of aging creeping in. Recall last night's dinner and sketch out your agenda for the weekend as if time is this unyielding linear path propelling you inexorably onward. But what if I revealed that this perception is nothing more than a clever deception, a cognitive sleight of hand concealing a profoundly bizarre truth about the fabric of existence? Do you and take click away just yet? We dive in deep into unraveling the myths you've held about time, and if you haven't subscribed to the channel already, smash that subscribe button now to catch every eye-opening episode that challenges your worldview. Let's begin right at the source of the misunderstanding. Inside your own mind. Most people assume their innate sense of time is precise and trustworthy, akin to a built-in chronometer ticking away reliably. In reality, it's a tangled web of cognitive adaptations that vary dramatically across individuals. To illustrate, try this straightforward mental exercise. Silently count up to 60 seconds in your head. No vocalizing aloud. For many, this involves an internal monologue reciting the numbers 1, 2, 3, and so on. If someone starts a conversation with you mid-count, that mental rhythm breaks. The process derails entirely, yet for others, the experience is visual, perhaps envisioning a measuring tape unrolling with numerals flashing by, or a mechanical counter advancing click by click. Individuals with this visual approach can effortlessly juggle other tasks, like flipping through a magazine, examining intricate designs on fabric, or even sorting through a drawer of miscellaneous items, all while maintaining flawless timing. This disparity underscores a crucial point. The sensation of time elapsing is an objective constant, but a personalized neurofabrication molded by your biology. It's highly individualistic, not a shared universal metric. When shifting to the realm of physics, we must abandon these subjective impressions entirely and adopt a strictly operational mindset. Philosophical musings on the nature or essence of time belong in casual discussions over drinks. In science, the key question is pragmatic. How do we quantify it? Fundamentally, time serves as a framework for organizing occurrences in sequence. Visualize a collection of snapshots spread out on a surface. One image precedes another, which in turn leads to the next. The snapshots themselves remain static. The progression is inherent to their arrangement. Time functions as that foundational layout, not as a dynamic flow carrying events along. This perspective dismantles one of the most pervasive misconceptions. People often conceptualize the universe as an immense void, with time operating like a perpetual clock mounted on its boundary, continuing to advance regardless of what's transpiring within. Even if you hypothetically eradicated every star, planet, particle, and photo-living outer stillness, time would purportedly persist in its relentless march. This notion hails from classical physics and has long been debunked. Time isn't an autonomous canvas upon which reality unfolds. It's intrinsically linked to transformation and motion. In a cosmos where nothing alters, no atomic vibrations, no electromagnetic waves propagating, no quantum fluctuations, time becomes utterly meaningless. Defining a unit like a second demands a tangible phenomenon to calibrate it against, such as the swing of a pendulum, the resonance of a crystal, or the hyperfine transitions in the cesium atom. Time isn't detached from the material world. It's an emergent attribute of that world's components. Intuition often rebels here, insisting, surely time exerts influence it, drives the aging process, causes fruit to rot in the bowl. Not so. This is a subtle error in how we phrase things. Time lacks causality or volition. It doesn't actively intervene to curdle your milk or wrinkle your skin. Those effects stem from biological decay, chemical interactions, and thermodynamic processes. Time merely provides the coordinate system for monitoring their pace. It's analogous to attributing the erection of a skyscraper 2 meters measurements don't construct. Engineers and materials do. Time logs the intervals, but it isn't the architect. Now, prepare to amplify the strangeness. What if this coordinate system isn't fixed and immutable? Indeed, it's malleable, as confirmed through rigorous empirical testing. Historically, we presumed that durations were invariant across the cosmos. A second on our world equated precisely to a second on a distant star. Dispatch a timepiece to Jupiter, and it should harmonize flawlessly with its terrestrial counterpart. This assumption crumbles under scrutiny. The tempo of timepieces is modulated by gravitational fields and relative velocities. This isn't due to mechanical imperfections. It's a bedrock principle of the universe. Consider this analogy. You're perpetually traversing the continuum of space-time. at an invariant velocity, the speed of light in a vacuum. However, this velocity is apportioned between spatial displacement and temporal progression. When stationary relative to your entire allotment funnels into Ti mu, advance through the future at peak rate, 1 second per second, but initiate movement whether strolling across the room or accelerating in a high vehicle, and you reallocating a portion of that velocity to spatial traversal. Consequently, your temporal advancement you experience less time passage. Biological aging slows. Approach the velocity of light itself, as photons do, and all velocity dedicates to space, leaving none for time. From a photon standpoint, emission and absorption occur simultaneously. Vast cosmic distances compressed to zero duration. The expanse of reality appears timeless and immobile. Naturally, you will detect this during everyday activities like sprinting to catch a train velocities at human scales. Yield negligible discrepancies. Nevertheless, these effects are measurable and vital for modern technology. Global positioning system satellites hurtling through orbit at elevated speeds and in weaker gravitational pull necessitate precise compensatory adjustments to their onboard clocks. Without such corrections, navigational errors would accumulate rapidly, rendering directions inaccurate by kilometers in mere hours. Next, address the apparent unidirectionality of time, the so-called arrow pointing from past to future. Why can you recollect yesterday's events but not tomorrow's? Many fundamental physical equations are time reversed. They function equivalently forward or backward. Observe a simulation of celestial bodies orbiting, reverse the playback, and it still adheres to gravitational laws seamlessly. Contrastingly, record a vase tumbling and fragmenting, then reverse it. The shards don't spontaneously coalesce and ascend back to the shelf. It defies credibility. The distinction arises not from time's inherent bias, but from statistics and disarray. Coherent, ordered configurations and unbroken vastes are exceedingly scarce, whereas disordered states, scattered fragments, and myriad arrangements are overwhelmingly probable. Systems evolve toward greater randomness simply because there are exponentially more pathways to chaos than to order. This progression is quantified as entropy, the measure of a system's the directional flow you perceive as your cognition registering this entropy escalation. The past registers as immutable because it corresponded to lower entropy states. The future looms as indeterminate, owing to the profusion of higher entropy outcomes. Envision a universe at thermal equilibrium, utterly homogeneous, with energy uniformly dispersed and no gradients for change. In sac stasis, distinguishing sequence becomes impossible. The arrow dissipates entirely, as no discernible evolution occurs to demarcate before from after. As humans, we've developed these internal chronometric mechanisms through anticipating threats, coordinating hunts, or aligning with seasonal cycles. They're optimized for practicality in our niche, not for unveiling cosmic verities. The notion of the present moment seems synchronized when in proximity, but extend the scale. For an observer on a remote galaxy receding at relativistic speeds, their simultaneity plane intersects the spacetime manifold at a divergent angle. Events they deem contemporaneous might lie in your historical record or impending horizon. There's no absolute cosmos encompassing now. Existence manifests as a four-dimensional manifold of interlinked events, with your experiential cross-section contingent upon your trajectory. This framework contravenes intuitive expectations, engendering apparent contradictions, yet relinquish the anthropocentric urge to envision time as a fluid torrent or sequential tally, and reconceptualize it as a spatial-like dimension susceptible to curvature, dilation, and contraction, and the enigmas resolve. Mathematical formulations align coherently, yielding predictive power. Still, a profounder conundrum persists. The origin extrapolate the cosmos's expansion in reverse, and it converges to an infinitesimal, infinitely hot singularity, the Big Bang. At that juncture, our descriptive paradigms falter. Since time quantifies intramural dynamics, inquiring about precedents to the universe's inception may equate to nonsense, comparable to querying the terrain north of the North Pole. Syntactically sound, yet conceptually void. Time might commence concurrent with the cosmos, sans antecedent epochs. Our psyches, wired for narratives with infinite regressions, resist this finitude, fostering tension between innate predispositions and cosmological inference. We are ephemeral entities, assemblages of neurons and synapses endeavoring to fathom the eternal with rudimentary apparatus. Newtonian mechanics sufficed as a rudimentary tally. Einsteinian relativity furnishes a sophisticated visualization for intricate phenomena. The transition demands jettisoning cherished paradigms, like the poetic fluvial metaphor for time. Though arduous, the recompense is enlightenment. Despite relativity's subtleties lurking beneath quotidian experiences, permitting you to schedule appointments or synchronize watches, the awareness elevates appreciation. Revisit those diverging counting modalities, the auditory reciter versus the visual image, in dialogues on abstruse subjects, quantum mechanics, or existential quandaries. We presume mutual comprehension. Affirmations abound. Yes, I get it. Beneath the surface. However, intricate interpretive filters operate. My articulation of temporal dilation might evoke in you a contorted hourglass or an auditory disparate from my mental model. Consensus appears superficially, yet cognitive architectures diverge profoundly. This elucidates why common sense often misleads. It's an accretion of idiosyncratic biases, not immutable truth. Mastering esoteric physics entails not mere accrual of data, but a radical reconfiguration of foundational skills. Countering evolutionary wiring, that's the exhilaration, the intellectual odyssey. If this exploration has appended your conception of time, hit that like button hard. Share your most mind-blowing takeaway in the comments, and subscribe immediately for a steady stream of paradigm-shifting content. What's the next enigma we should dissect? Sound also below. I read every suggestion.